Okay, you probably should hang on to this,
okay. And I guess
you could be the roving
right?
reporter who answers questions, or you're going to need it anyway for your talk. But
Actually, Robert's volunteered for that position.
oh, okay.
So
See, I think it might still be muted. Let me take a look. Yeah, just hit the mute button. Not the other one. No, not the other ones, because that does weird stuff.
they already hit the.
It's actually labeled mute
Okay,
there.
mute. Oh well, that's
the one on the.
This is mute.
Yeah.
And you're going to be the person that runs
the roving
mic around?
reporter.
Yeah. Okay, so I'll give you this effect if you're talking, and then you could just go up to people.
Okay, so how does this work?
Just hold it up.
No.
Well, the actual microphone's on top, so don't cover that. Don't push the other buttons.
Okay, so
so here's the thing. It says mute over here.
Right.
So that's if it's muted, you see nothing.
All right.
That's your signal strength there.
So that's the button your thumb is on?
Yeah, it says mute.
Yeah,
And
okay.
that's really pretty much, you don't need to use the others.
So when you hand this to people, they're gonna do what? Talk to.
Well, I think you just hold it out near them. I mean, it's not, you don't have to be right next to them.
Okay.
But be aware, the actual microphone itself is here, so don't cover that up.
No, I understand.
Okay. Well, I'll give it to you as soon as I get them talking.
Muted, right?
And then you'll be in good shape.
Okay, so you're all set up with the.
Good to see you. Hi. Welcome.
I-45 is down to one lane in each direction.
Oh, not again.
Oh, wow. I think it's because they're like,
Yeah.
they're like
So I think this
doing
should be
some.
working. Yes.
Oh,
You're good.
excellent. And we're right on time, right?
Yeah, I think
Yeah,
so.
excellent. Well,
Yeah.
not unusual. I feel like
We can fix that.
Well, thank you all so much for coming to the August North Houston Space Society meeting. We meet once a month here, except for hurricane months. Anyway, good to have you here. So the agenda for the day is I had some opener remarks, and then we'll have Patricia give us an update on recent space weather. And then Greg's going to give us an update on space news. And then we'll have our feature speaker, Rasha Sharim, talk about venturing into a cosmic career, about her exciting journey and doing NASA contracting. And then we'll look to wrap things up about 4 o'clock. And for those of y'all that want to hang out, we'll meet up at PJ's later on. And I have a few books that I was going to give away. One is actually Into the Unknown, which we actually had the author come and speak to us a couple of years ago. And then Space Bites, which is written by Vicki Coloris. She ran the food lab at NASA, and she actually spoke to us during COVID times, so she'll be coming back here in a couple of months to also talk about her work.
Sound getting.
And Patterns of Orbit, which is a book of sci-fi short stories. And also I have 5 PJ's gift cards, which will be given away. So if you haven't already, just go ahead and sign up for the drawing. And yes.
Be sure to mention to everyone to take copies of the Ad Astra magazine. They're free.
Absolutely. Ad Astra magazines are free. The National Space Society sends them out to us every time they publish a new edition, and they are free for you to take. And they have a lot of. That's true. That's true. Well, as a way of getting started, I have 4 reasons for why you are in the right place right now. So, reason number 1 is you believe humanity has a future, which I think is an important thing to think about. The investments that we invest in today, other people will benefit from them. The shortcomings that we have today, other people will be worse off for them. So it's a big responsibility whenever I think about humanity's future. So, and reason number 2 is you see the Earth as a as an infinitesimally small part of an imaginary big universe. Now just try saying that 3 times fast. Here's a picture of Earth from low Earth orbit. You can make out the solar arrays of the space station right there, and I think that's a Soyuz right there. But as you get farther away from Earth, this is from the lunar surface, you can see how small Earth really is in terms of the scale of the cosmos. In fact, this was taken from one of the rovers on Mars, and Earth is just a little bitty dot, just like one of the stars that we might see in our night sky. And if you were out, say, where the Voyager space probes are, even if you zoomed in really a lot, you would only see just a little bit of a reflection of a star. And whenever you can compare the size of that star to how big, say, our Milky Way is in terms of the billions of stars, each of which have planets, it's really amazing to think about some of our, say, territorial disputes, which are in the great cosmic span of things, aren't even like arguing over atoms, but more like subcomponents of quarks in terms of how small it is in terms of cosmic scale. So that's reason 2. Reason 3 is you feel that the universe should be filled with life and civilization. Now, as far as we know, Earth is the only place that has life and has intelligence. I know I've heard the jokes about even that's questionable, but I believe we do have something special going on here on Earth. And I think it would be good for what started out here on Earth to expand to the rest of the universe, to have a base on the moon, to have a base on Mars, to develop, huge artificial worlds which could be sent on voyages to other stars. And reason number 4 is you want to play a part in making it happen. Be it just kind of like learning more about it for yourself, talking to other people about this vision, perhaps getting a career in space, starting a space company, helping somebody else get a career in space or start a company. You want to play some role in it. So just to recap, 4 reasons why you are in the right place. You believe humanity has a future. You see sort of like the scale of the universe and how much more potential there is for humanity. And you want to actually go and see that potential realized, and you want to play a part in making it happen. And so with that, let's do the space weather. And
Nobody got up and left.
that's good. So y'all are all in the right place. Let's see. There we go. And there we go. Oops. Go back. Yes. Okay. Awesome. Oh, I give this to you.
Oh yeah, I forgot about that part. Okay, hi. It has been a lot with space weather. According to the Space Weather Prediction Center, we may have actually reached solar maximum officially, which is a lot of fun. You'll see on here, this is near the peak of the last solar cycle, and that's pretty much where we are now. I don't think they've updated for August on this graph. But it has gotten to be a lot. And they actually called the peak for solar maximum on August 8th. We won't officially know until after everything is said and done if this is the actual peak. But we have had the highest sunspot number in what they said is 20 years at between 299 and 337, depending on which count you go by. Also on August 8th, we actually had 5 really, really complex solar regions. And all of these were capable of producing X-class flares. That day we only got one X-class flare, but the day before we got a double peak. And then I don't think we've gotten one since then, because that was just 2 days ago. And since then, some of these have been downgraded to less complex because they've burnt out a little steam. And sorry, only my second time giving a talk like this, so I'm still learning. One thing that has been really, really impressive about the solar cycle was actually this flare on July 23rd. And this is actually a far side eruption that gave us an S1 radiation storm on this side. This was actually an X14 flare. And it was very, very large and very, very intense. And the fact that we got radiation on the complete opposite side is really impressive. There haven't been too many that have been really impressive on the corneographs, but this far side, I think, has been the peak since the last talk. Let's see. We've had several solar storms, several minor solar storms, lots of aurora in like the North American Canadian border. Some have gotten a little further down. Nothing like the May 10th storm. Unfortunately, that was a lot of fun, but we haven't had anything like it since. Okay. Does anyone have any questions? Yes.
Is there any after effects with global communications because of that thing showing up there?
Because
Does it have any repercussions?
That one, no, because it was farsighted.
Okay.
And so the big blast of energy that it shot out, thankfully, was shooting away from us. Oh. It depends. The way the magnetic fields are set up, there's different formations of magnetic fields. And also if they have delta regions, which can make more different formations, space weather is just as complex, if not more complex than Earth weather. And so it's a lot. I am still learning about all the different forms and structures and all that good stuff. Oh, yes.
All right. Not too familiar with any of the rating system. Like one mean, like a baby.
It kind of goes like, okay, if you know like metric scales, so like C class would be centimeters, and then M class would be meters, and then X class would be kilometers. And so X is the highest class we currently have. And so that's like one kilometer of a flare versus an M, which would be like, an M5 would be like 5 meters of a flare. And that's just an analogy, but it works kind of on the same system.
So,
Talking to it. Just
okay,
talk,
all
talk.
right. So then, like, this is a more active time than usual. Is that right?
Yes.
Okay.
On here, it'll show the sunspot numbers. And so you can see that like even the peak of the last solar cycle didn't reach where we currently are.
The way that this translates to over here on Earth is going to get hot.
It could. We
Okay.
could get more solar storms. It can have impacts on Earth. There was a solar storm, I think, in the 70s that caused landmines to go off. But, yeah, I think they were like the underwater mines. And because of the variation in the magnetic field, the mines thought something metal was passing in front of it. Also, in 2003, there was a huge solar storm on Halloween that produced tons and tons of aurora, even down to similar to the storm we had on May 10th. This one?
No, the one ahead of that.
Oh, this one?
No. It's like blue in color.
Oh, yeah.
Can you just describe the different features of it? Like, what are we seeing?
Okay, with this, you'll see, okay, where's the pointer? Okay, here we go. This, it actually looks like a combination of flares. So this right here would be the halo for the far side. And then this right here actually looks like a different flare that was going off at the same time, which happens. There's something called, I forget exactly what it's called, but it's like a sympathetic system. So when one flare goes off on one side, a lot of times another flare will go off at the same time. Kind of like how when volcanoes erupt, there'll be earthquakes in a neighboring region.
Okay, that makes sense. The sphere, like the blue sphere, is that the sun, and then or is the white, is that the Coriolis? Or?
Oh, yes, I'm sorry. This one actually has a cover on the disk, so we're only seeing the corona and the energy produced through the corona. There's a lot of different imagery that you can find. The different wavelengths of light, you'll be able to see different things.
Okay, thank you.
Online,
Oh, yes.
do the solar flares correspond with earthquakes? For example, the possible megaquake in Japan this week?
There are some people who think there is a correlation. I am personally on team, there's a relationship there. We don't understand what that relationship is right now. I mean, I've heard theories, but I don't think anyone knows for sure at this point. Anything else? Okay.
Okay, so this is recent space news. It used to be monthly space news, but we didn't meet last month. So this will actually cover just a few selected things from recent things going on. First, we'll start off with the space station. Several things going on there of interest. I mean, one is figuring out what to do with it. It's near the end of life, but it's not there yet. And there's been actually quite a bit of controversy over just what to do. NASA did just award SpaceX a contract for basically a tug to deorbit the space station. And that's like $843 million. That doesn't include launching the tug. So that's going to be a separate contract. The whole thing will be like $1.5 billion. They haven't actually said even what they'll use. I mean, everybody would assume it's going to be a Falcon Heavy. Apparently it's too big to do this on just a regular Falcon 9 like you might expect. So that contract hasn't been let yet. But what they're going to do to accomplish this tug is essentially they're going to take an existing design, which is the Cargo Dragon, which is what takes cargo to the space station now, And it kind of makes sense that either SpaceX or Northrop Grumman were about the only two people that bid on this, because they're the ones that know how to do the docking and all these kind of things that really nobody else would have any experience with. So it came down to just a few people. But so the Dragon was going to be likely part of this. But what they're going to do is take the trunk part of it, which is normally where there's just, engines and a little bit of fuel, make it a whole lot bigger. Put a whole lot more fuel in there, a whole lot more thrusters. So instead of having 16 engines, they're going to have 46. 16 is a normal component, and 35,000 pounds of propellant. So it goes way beyond what the normal cargo would be for going up there. The plan is it would dock way before we're actually going to do the deorbiting, and gradually operations would wind down. It'll stay there docked for 18 months, and it'll be, the orbit will continue to decay. It always is decaying because there are a few air molecules up there even at that altitude. And so it gradually decays. And then they're going to do some final burns after 18 months. And the intention is, of course, it will come down. A lot of it will vaporize, certainly the small parts like solar sails and that or solar arrays and that sort of thing. Big, heavy parts will end up being dropped in the ocean. So, of course, they're going to try to do this to aim, for the ocean. It'll be probably a 1,000-mile stretch in the ocean. Typically, they do this over the Pacific. There's kind of a standard spot where they do this kind of thing. That's not unusual. It's just never been done on anything of this scale before. I mean, the thing does weigh, 990,000 pounds. So it's a lot bigger than your typical car or something that you might normally try to get rid of. So the plan, though, is, parts will vaporize and then the rest will drop in the ocean. Now, the thing is, a lot of people really don't like this very much. There's been a fight. This has been going on for years. It's not new, but it's getting louder and louder now that it's starting to actually happen. And contracts are being let. So the obvious thing is, certainly you could have a garage sale and have parts. Like some of the things like solar sails, they're still putting new stuff up there. One would think that they could reuse some of that stuff. And we had somebody here from Axiom Space, which is tying in, and I suggested that they could do some midnight rage, surely. Near the end of life, they're going to be attached to the space station. Surely they can just kind of sneak in there and grab some of that stuff, because otherwise it's just going to get burned up anyway. So one would hope that at least some of that will get reused. There are a lot of people who think it ought to be a museum. Just keep the thing around. It is a major part of our history, and in particular the history of space exploration. One way to look at it, I think, for the future, we're not ready to do this yet, but in the future you'd like to have kind of a circular economy going on up there, where things that go to space stay in space, rather than just coming back and essentially polluting the atmosphere with aluminum and titanium ions. Keep it up there, because it still costs a lot of money to raise stuff up. Even with Starship coming along, lowering costs, it's not free to put stuff up there, and you've got that much stuff. It makes more sense to have foundries. You can just melt down. It's mostly aluminum. You can melt a lot of that stuff down and build new structures, like things supporting solar panels for space-based solar power, that kind of thing. The problem is we don't have the technology really to do that yet, so it's a little premature. But people have said, well, okay, take the same thrust, and instead of using it to slow down the orbit and drop the thing in the ocean, raise it up. It's about 400 kilometers now. Take it up to 800 kilometers, where you can have a stable orbit where it would last for a long time. So those kind of arguments are still going on. But of course, in the meantime, SpaceX will start working on producing this thing. One big problem really that's lurking behind all of this is simply that if you try to save the space station, what happens when things go wrong? Parts fall off, satellites get destroyed, that kind of thing. Who's going to pay for that? And when you get right down to it, liability, especially in America, but really anywhere, it actually makes it so terrifying, I think, to NASA or anybody else, that probably that may actually be the thing that really dominates. It probably will keep them from doing anything other than just dumping it in the ocean.
Lawyers in space.
Yeah. Well, we always said, when we go to space, people used to think of astronauts as being all you needed to go to space, but really every job on Earth has a counterpart in space someday. And that as that time goes on, there will be people. There's going to be people that are going to be doing mining of asteroids. There's going to be people running foundries to melt down old aluminum and steel and make new things. And there's going to be people doing agriculture, all these things. So, yeah.
Has anybody made any calculations on what it would cost to manage it if they pushed it into outer orbit?
Probably. I don't know those numbers though, but
Well, I would think,
I'm sure that the people at NASA that want to dump the thing have come up with very large numbers. And the people like Rick Tumlinson that want to save it probably come up with very different numbers because you make assumptions, and that's a typical problem with any of these studies is that really people have a solution in mind a lot of times. And if they want it to look expensive, they can make it look expensive. If they want it to be cheap, they'll make it cheap. It's really unknown because you don't know how well it's going to hold together. People always said, well, you can't really push the orbit up higher because the whole thing will fall apart. Well, if that's true, the same is true when you slow it down. Either way, you're applying the same amount of force. So, I would take all of those estimates with a grain of salt. Okay. Oh, lost it already. Okay. Now, the other big story, of course, coming out of the space station is tied in with Boeing and its Starliner. And I think everybody has probably heard of this one. The Starliner took up, as a test flight, took up 2 astronauts to the space station. They had some trouble along the way, and a little bit of trouble getting in, but they finally got it there. But there was a lot of concern because the thrusters, the small ones that are used for making adjustments to come in, for instance, to dock, or any kind of positioning in general, they had problems. And several problems came up. I mean, one was the thrusters themselves. Another was the software associated with it. There were also problems with helium, which is providing the pressure to keep all this stuff going. And they had seals that had degraded. And so they're trying to figure out, well, what really are exactly the problems and what are the root causes of them? And they wanted to do this, they wanted to learn all this. They have to do it while the thing is still there. And the problem is that all these thrusters and systems, they're all in the Starliner, and when that goes back down, what's called the service module gets vaporized. It's only really a small cabin left for the astronauts that get saved. So any of the evidence for what happened would be destroyed. And so, of course, they want to hang on. And that's been the official story, and it does make sense. You want to do the troubleshooting. But it's now gone on quite a while. So the main issues here are there's really not a really definitive root cause analysis of all the problems. I mean, they've identified some. It's not clear why some of it's happening. There's a theory that the thrusters are getting hotter than they were designed to. Maybe they didn't design adequate cooling for them or something. And there's some valves that let in the fuel and the oxidant. And there's seals, there's Teflon seals on this. And apparently they found that they've gotten kind of extruded and they may be restricting the flow. Things aren't really working the way they're supposed to. That's still kind of working theory. It's not 100% definitive. And that's what makes everybody so uncomfortable, is they're not quite sure what's going on. So the question is, what are they going to do about it? So there's several possibilities. One is to just put the astronauts, 2 astronauts, back on that same Starliner, send it back and hope for the best. I mean, that's one thing, but of course that makes everyone nervous. Another approach is, well, the next mission going up, which will be on a Falcon 9 with the Crew Dragon on top of it, take that up and just leave 2 empty seats. You normally take 4 people, but just take 2, and then when that returns in February, then which would be the normal cycle for that, go ahead and bring them back at that point. Now, there is some problem here, because that assumption says that you have to then undock the Starliner automatically. Now, they've proven they can do that in the previous test a couple of years ago. However, they apparently removed all that software because they said, well, this is a crewed mission. We assume there's going to be a crew on there. And which was true, of course. They did have a crew, but but they apparently somehow just misplaced the rest of the software. So now what they have to do, even if you want to just throw the Starliner away, just let the thing vaporize in the atmosphere, you have to get it away from the station safely without crashing into it. That's a concern. So they don't have the software to do it. So for some reason it's going to take weeks. Now obviously an upload doesn't necessarily take that long. However, the testing for it to really make sure that it's really right, because it hasn't been used in a couple of years, they say you're talking a couple of weeks. So you need that if you want to just even use a Crew Dragon to rescue them. And it's worse though. If you take the 2 astronauts and you put them back on the Starliner and send that back to Earth, what they found was apparently the stress of manual control went beyond the normal limits that those thrusters were designed for. So that actually they think that's partly what has caused them damage. So they're actually kind of afraid to do that. They said that even if you put the astronauts on the Starliner, and you want to go away, you better do that under automatic control, not manual control. And so to do that, you need that software. So either way, they have to do the software. And some people have suggested, well, that's one of the reasons they've delayed the next flight up to the ISS with crew anyway, just to make sure they can get the new software in there and test it. And testing is the big thing. So yeah, people are saying the astronauts are stranded, and it's kind of looking more and more like that's an appropriate word. There's no imminent danger. They have plenty of supplies to last for quite a while, and they still can bring in cargo. But anyway, it's sort of a mess right now, where nobody's quite sure just what to do.
Just briefly, one or two people here are have computer experience. The software to bring back the vehicle automatically without a crew would fit into something the size of, I'm guessing, a cigarette pack, a pack of cigarettes, 2 packs of cigarettes.
Well, actually, it's more like a fingernail inside.
A fingernail, and they didn't put that on as a plan B.
Yeah,
That's kind of almost indefensible.
it is. It basically just says the people who design. I think Boeing is just not any good with software. We've seen that with planes and everything else. They're not good at designing systems that are run by software. Period. And having a user interface for it. It's just you put those things together.
We're going to note in chat, Mr. Bond, that it sounds like the problem might not be the software, but a configuration file that needs to be updated.
Well, that's true, but the real issue is, and that doesn't necessarily take that long, but they still have to do the testing. And that's because it probably won't be exactly the same set of parameters they might have used a couple of years ago. And so if there's any differences at all, they're going to end up wanting to test that. So that's what they're saying. Most of the time is going to be in the testing, not in the actual upload is inconsequential.
So is there a Boeing supervisor somewhere who's saying, oh, we saved 1 thumbnail's worth of mass on the upbound trip,
That memory is still there, I'm sure.
and look how much we saved.
In fairness, what probably happened is that the crewed and uncrewed were parallel software development that were, they were probably developing the crewed software, independently of the uncrewed.
Could be, yeah. Yeah, they just got it out of the way so that they would make sure that they wouldn't run it by accident or something. But the thing is, anything these days is usually a mixture of some automation and some manual operations, and you almost always want to have one or the other available, or both available as a choice. Yeah, I mean, the idea that they just kind of completely removed a basic capability is just nuts.
I would imagine they were something like the uncrewed test flight software. Wondering, one another one, they just never bothered to merge.
Yeah,
that over, just.
It all could be, but in any case, they just don't seem to know how to manage it
Not good. So, Robin asked online,
Hard to
who do
believe.
you think might be able to do an unbiased estimate of the cost to keep the ISS up?
I don't know who has that estimate. I mean, everybody's throwing around numbers, but mostly they're talking concepts and who would you trust?
Which numbers would you trust if they were to apply their estimation?
Yeah, it's one of those things where it's gotten so emotional that I'm not sure I trust anybody's estimates. They're going to be so slanted based on the conclusion they want to reach. I don't know. But the thing is, you're talking about risk, and that's why it's hard to quantify anyway. Part of it's risk. Will the thing break apart? Will it hit other stuff on the way? What happens if it does? And that's where you get into things where you're estimating probabilities for things that don't normally happen. You don't have good ways of estimating any of that stuff. So that's why people can make up all the scenarios. You have to make up some assumptions, if you're going to make an estimate of cost. And it's all based on stuff that is unknowable. So.
Life insurance. We're just all.
Oh yeah, actuaries.
I'm 35% confident of this now.
Yeah, well, that's the thing is actuaries have data to work on. They can look at deaths and sicknesses and everything, and they have those statistics for 100 years. We don't have any statistics on any of this stuff. So.
Yeah, we have 6 space stations to base define.
Yeah.
Yeah.
They're all very different.
Yeah, and actually, people have crashed into space stations before. It's not the first time. It happened with a mirror or something. So anyway, Okay, better move along here. Okay, a little bit on lunar missions, and this will, some of you will kind of, you'll realize there's kind of a trick in here. Anyway, there's a program that NASA had called the Viper, and it stands for Volatiles Investigating Polar Exploration Rover. It's a rover meant to go to the moon to look for deposits of ice. And that's actually pretty important because if you have ice, you have water, you know, if it's in large quantities, you can fairly easily melt it. You can, of course, you can use that for drinking, but more importantly, also, you can generate hydrogen and oxygen by electrolyzing it. You can also make rocket fuel out of that. At least you can certainly make the oxidizer parts, you know, the oxygen pretty easily. So it's considered that, you know, there's kind of a race going on for resources on the moon, China being the main participant at this point. And so prospecting is kind of a key part of that. And that's what this is really about, is figuring out what's going on. Now there's scientific value as well, just figuring out, you know, what is really there, how did the moon form, and all this kind of thing. But when you get down to it, it's kind of an economic issue. Where is a good place to put a base where you can actually start to use these resources for your own survival and as well as an economic benefit. And actually, in particular, it was also stated that it would help in site selection. When you're going to have your crewed landing, you know, you want to pick a place where, of course, there's going to be some of these resources. And then longer term, where do you put permanent bases? Again, you want to have access to resources so that you can survive and possibly have economic benefit. So what are some of the challenges? Well, this is sort of different because the plan here is actually go ahead and drive right into the dark craters. No one's ever done this before. I mean, everything has kind of been on the surface. They actually want to go in. They're saying the really cold spots on the moon where the ice could survive would be the dark craters that are permanently dark. There's a lot of those, especially at the poles, because the sun comes in kind of horizontally, and as a result, they're eternally dark. And so, but you got to drive into them to see what's there. We don't have any data on that. And they were going to take in spectrometers for doing analysis, mainly looking for water is the main thing. They were going to look, of course, what's on the surface, you know, in those craters, but also drill in a meter, 3 feet, and also get a feel for what's underneath. And what they would do is then they would drill, that would kind of bring up pieces so they could really see material that was present all the way from the surface all the way down to a foot. And you say, well, okay, this is great. We've done rovers. This should be a piece of cake, right? Well, we've done rovers on Mars, and it turns out actually it's probably tougher on the moon for a whole variety of reasons. One is the temperature variations are much, much greater, 500 to 600 degrees Fahrenheit. And I put a range in there because it depends on exactly where you're talking about. But you figure the hottest it gets is maybe, I don't know, 250 or 240 degrees Fahrenheit during the daytime. At night, and if you're down in a crater, people are saying it gets as cold as 400 degrees Fahrenheit, minus 400 degrees, which is only 60 degrees above absolute zero. So that's a whole lot worse than Mars. You know, Mars, you have more of an atmosphere and wind and that sort of thing, and it tends to equalize temperatures a lot more. This is a much more drastic variation. You have to design the system to handle all that. You got to keep cool, so they build all kinds of heat pipes and things into it that you don't necessarily put in other places. You have a whole lot more insulation, you know, just basically to mitigate all the temperature extremes. At the poles where you're going to be here, also the shadows are very deep and they're very fast moving. I mean, you can imagine, well, it's just the way it is. Now, the other thing is that typically when you're designing for the moon, you have to deal with the really long nights. You know, it's a 28-day cycle, so you typically have 14 Earth days for a day and 14 Earth days for a night. And of course, you got to survive all that. That's pretty hard to do. That makes it much tougher on the moon. Now, it's kind of a little different at the poles, though. Down at the poles, actually, if you're up at a high elevation, you have access to the sun. You know, maybe you're only out of it during the lunar summer. It's only maybe 4 Earth days that you're actually out of the sun. And so they have to design a mission that the rover can also climb up to the high spots during the long nights, because this is not powered by any kind of radioisotope generator like a lot of the long-lasting rovers are. It's still just solar powered. And so they have to be able to go out and bask in the sun, essentially, to keep warm and to not have to last so long. Another problem is they can't really be quite sure what the terrain really is like there. There could be areas where there's a lot of really soft dirt or really hard terrain, especially when you get down into these craters. They don't really know what it's going to be like. So they made the wheels much more versatile. they essentially can lift up and down and rotate around quite a bit more, so they can kind of walk if they have to. If the wheel gets stuck, they can kind of lift it up and they can almost do kind of a walk, a slow walk with the thing. They can turn on their own radius, which is a little tighter than say the Martian rovers have been able to do. They can spin in a circle. They can drive sideways while facing the same direction, all this sort of stuff. So they end up with a golf cart-sized rover, solar powered. It has headlights. Never had headlights on a rover before. Never needed it because they weren't going down into craters. And it must have a really big battery because it still has to last for 4 nights. It has to last while you're going down into those craters, and you don't have any solar power either. So it's kind of an interesting, actually it's kind of an impressive technology demonstration, really. It costs about $450 million to build. This is quite a bit more than the typical project that was done as part of the commercial lunar activities that NASA's been doing. Anyway, it's built, and it's sitting at Johnson Space Center right now, waiting for testing. It's been built, but and there's some testing that has been done, but more is needed. And it was going to be delivered on the Griffin lander, which this is the product of Astrobotic. Remember, Astrobotic's first lander didn't make it. They failed along the way with a valve problem. The Griffin lander is quite a bit bigger, so this is a brand new one. And people have criticized NASA for putting a very expensive rover like this on an unproven commercial platform. But anyway, both Viper, for various reasons, and Griffin, both of them were delayed and were scheduled for 2025. So that's the current plan. However, NASA killed it. There were a lot of budget. They are actually having budget limits. And they were on July 17th, they announced they were killing Viper. And what happened was they said, well, it looks like, when you throw in the cost of testing, which was it was only an additional 80 million or so, but it would have gone past 30% of the original budget, 130% of the original budget. That automatically triggers a termination review. And so at that point, that means you got to do a lot of analysis. You probably have to report back to Congress and get special funding and all that. So NASA has a decision to make. Is it worth fighting for this or is it not? And they decided not. I'll drift over strictly into opinion here. This is not fact, but from past behavior, it's pretty clear NASA, they want to focus on science and exploration footprints kind of things. They're not interested in things that are more supporting the space economy, like development of a space economy, or even a sustained lunar surface presence. That's just not their thing, and they pretty much said that. And the big bucks, so there are people that are doing all this, but the big bucks are still going for the Moon to Mars program, which this is actually nominally a part of, but when it gets down to what gets cut, this is something that's more oriented towards sustainable operations on the moon. They're not that interested in it. So, and they made it especially obvious by saying, that was July 17th. They said, okay, if you have an alternate proposal for what to do with this thing by August 1st, let us know and we'll consider it. So they gave people 2 weeks to figure out a solution. That's not really enough time for any serious engineering. By the way, this does repeat past history. There was a similar mission 6 years ago that was also killed. And that was actually announced the day that a new NASA administrator was coming. They decided to kind of close out his options. They just said, okay, we're going to kill this thing. And it was actually the same kind of thing. They said they're going to take it apart right away, and we'll reuse those parts on the next mission. So we're kind of just repeating history here. So what are they going to do? The plan is that 950 pounds that the rover weighs, they're going to send just dead weight, a hunk of metal or something. Now that's the plan. However, yeah, so that, but well, because you do want to demonstrate that the Griffin lander will work. I mean, that is also a NASA-funded project, so that's not completely crazy. However, you might say, well, why not just put the Viper as it is on there? I mean, what do you have to lose? But actually, Astrobotic is free to come up with other uses for this. NASA said, you can do what you want with it, apparently. So they have other projects for putting stuff on the moon, in particular for setting up a grid of solar power on the South Pole, where they put up solar panels way up high where they can easily get access to the sun. And they may do something with that. The problem is it's a short period of time. I mean, if they're going to launch it in 2025, to suddenly shift gears and get all this going, don't know if they can do that. So it's not clear what will happen. Okay, now on the other hand, I guess it's sad a comparison here. China has just finished returning from the far side of the moon They sent a, this is not a rover in this case, it was just a lander. But they took samples on the far side of the moon, communicated by a satellite they put up there, brought the samples back to Earth, dropped it in Mongolia, and we haven't seen too much on the results of that, and you probably won't for a while. But that was a 53-day mission. We've reported on it before, but now it's actually complete. Before the last time we talked about this, the samples were on their way back. They just lifted off the moon, and now they're back. They got about 2 kilograms of combination of soil from the surface and dirt from the surface and rocks, and also the subsurface samples. They also had a 1-meter drill, so they're going to have a lot of samples. I saw a report that I'm not sure is true or not, but someone said they found a lot more hydrates, meaning essentially a rock that you can easily get water from, because it's got the hydrogen and the oxygen bound into it. I'm not sure how credible that was, but there was sort of a leak. Usually it's going to be a couple of years before you get significant results back from these kind of things. Okay, so while we're at it, it's time for an update, I think, on some of the Chinese space programs. So we've talked about this Chinese lunar exploration program, actually in quite a bit of depth in one of our earlier meetings. And this, this particular lander and with the sample return mission, that was part of that. We've done that. And of course, there's other programs we've also talked about. Like they have a space station. They have other ones we haven't talked about much, like their Mars probe and some of the military uses, and even a planetary defense kind of a mission, kind of like our DART mission. But what I'm going to talk about here today is satellite mega constellations, meaning things like Starlink, where you put up thousands and thousands of satellites. And that is one of their plans, to integrate broadband internet with navigation and monitoring military uses and so on. They have an official national plan for this, kind of integrating it all into one system. And they pretty directly copied Starlink. That's pretty clear. After all, it works, so even if you don't even have to actually have any spying. There's enough published, just knowing that you can do these things, knowing that you can build the satellites, you can do communication links, that's probably enough, So they're going to build that. They also explicitly highlighted that, Starlink is very important for military use. And so they've highlighted that. They cite the Ukrainian example, saying they really need to have much more capability that they control. So they've said that. So we're talking about putting up thousands and thousands of satellites, just like Starlink. That would dwarf their current number of satellites, which is about 800 or so. And they actually, I mentioned in here that PLA, the People's Liberation Army, the Chinese army, they actually highlighted Starlink as saying they consider it a serious threat to the security of the space assets of various countries. So that's part of their plan. Anyway, they want to have a commercial space ecosystem by 2025. Now, this won't be complete by any stretch of the imagination, but it should be up and functioning to some extent. There's 2 major constellations going up. One's called Qianfan, or I'm not sure I got the pronunciation right. It translates to 1,000 sails is the name of it. And that's going to be about 14,000 satellites ultimately. But the launch has just started. I'll cover that next. The second one, Guowang, is called the National Net. And it's another one with 13,000 satellites that should start launching later this year. That's the plan. Now, there's some others that may or may not happen. The people that built the first rocket that used methane and oxygen and got to orbit with it, they own this other company called Hongqing Technology. They filed applications to build another 10,000 satellite constellation. ITU is the International Telecommunications Union. They're kind of a gatekeeper. Well, basically, the organizations that monitor any kind of telecommunications are kind of the gatekeepers for the satellite communications networks. And Huawei also wants to do its own constellation. So anyway, the 1,000 sails one has started. August 6th, they launched the first 18 of their satellites. They raised about $1 billion to construct it. So these are all nominally private companies, but they're all kind of ultimately controlled and owned by the state. So, but at least they are listed as separate companies. One bad thing that really happened here is that they had a lot of debris generation from this launch. The second stage just kind of broke up. And that's even right in the orbital plane that their satellites are in. So it's almost an immediate threat even to them. 700 pieces is not pretty. It's raising concerns that if this is just one launch of 18 satellites, when they have thousands of them up there, are we going to have more problems like this? Now, their plan has to be that they're going to use different rockets to do this. This Long March 6A, this has been around, I don't know, at least 10 years. The 6A version has solid boosters. It's really not that big of a launcher, but they add solid boosters on the side and they can get it up there. But it's the second stage that's breaking up, and it's happened before. The last couple of launches, actually, they've had this kind of problem. So apparently, we don't know why, but for whatever reasons, when they use these, they have them. So we think they're probably going to be replacing, and using different rockets going forward, because even for their own satellite constellations, they can't afford to have this much debris around. So their plan is 100 satellites for this year, 648 by the end of next year, and 1,296 in the first phase, which is within a few years anyway. The satellites themselves look a lot like the Starlink version 1. If you look at those, if you remember what they looked like, there was the body of the satellite, and then there was a solar panel on one side. It wasn't symmetrical like a lot of satellites had been. It looks just like that. They stored them for launching. They store them in flat packs, just like Starlink did. They are up at a higher orbit, though, 500 miles versus 340. But the Chinese know they have a problem. They need to get the launch costs down. So they're going to also be making a whole lot more launchers that are reusable to actually start competing with the Falcon 9. And I've listed 4 of them here. Land Space is actually probably going to be the first, and that one actually has a load that they can handle a payload pretty comparable to what the Falcon 9 can do. And they currently have, their version 2 is not reusable. But version 3 will be, and this can be based on, also like their version 2 is going to be based on methane and liquid oxygen. And there's several others that are a little bit smaller, but probably those first 2 are the most likely ones to be used. Okay, some other items here. Falcon 9 had a very successful record up until recently, and they had a failure on one of their upper stages. And what happened, they concluded, was that they had a pressure monitoring line for the liquid oxygen, and that line had a clamp that was apparently kind of loose, and with vibrations from launching and everything, apparently it finally broke, or at least made it leak. The liquid oxygen that leaked out cooled the engine components. That then interfered with their ability to restart the engine when they wanted to, or even start the engine, I guess, when they start the second stage up. The solution for that, so they were grounded for 15 days, and they finally just said, okay, we're just going to remove that sensor in line. They don't really need it anyway. They had enough redundancy with other sensors, so they're not going to use that. Now, they did lose 20 satellites at that launch, but of course, they've already got 6,000 or so. I mean, an extra 20 satellites is kind of nothing, when we get down to it, to SpaceX. That'd be the second time they've lost a batch of satellites. The last time was actually due to solar weather. They had launched, and they tend to put the satellites up in a very, very low orbit, which then the satellites themselves have thrusters and they raise themselves up. And the problem was there was a solar storm they hadn't accounted for. It heated up the atmosphere enough, the atmosphere got bigger, and there was enough extra drag that those satellites couldn't make it to orbit. So this is actually the second time that SpaceX has lost satellites. Now, this caused a bit of a temporary scare because, after all, the Falcon 9 is what launches the Dragon crew capsule, which was supposed to be the backup for the Starliner in case they really have too many problems with the Starliner to use it. But it was only 15 days. They solved the problem. So that problem has moved on. Okay, so speaking of SpaceX Starship, of course, that's the big one. Flight Test 5 is coming pretty soon. Flight Test 4, it was actually just, a few months ago. And it was, it was pretty successful. It pretty much demonstrated they can get a rocket up to orbital, pretty much to orbit, and they can actually get, at least under control, bring back both the first stage booster and the second stage. They proved they can do that. Everything else is kind of details at this point. They've already shown they can launch stuff, and they've shown that at least it looks like it's going to be possible for them to do the recoveries. Now, what's going to be different in this test is that they're talking about bringing a booster back to the launch site. Before, they tried to just drop it to a spot in the ocean, which they apparently came pretty close to hitting. This thing, they call it the chopsticks, but basically the booster comes back to the launch site, and these extra things go out and grab it. Now, this picture that's up here, that's just an animation because nobody has a picture of the real thing. The real ones, the real chopsticks that are there, they don't look like anything at all like this animation. But anyway, hopefully we'll have some real ones. But this is going to be definitely a step forward if they can do that. Along the lines of Starship, this has really been floating around. This particular picture, it's gotten a lot of attention because somebody put out a picture comparing the 3 different versions of the Raptor engines, which are what are used for Starship. The Raptor 1 engine, Raptor 2 engine, and Raptor 3 engine are there, and you can see it's going from a really complicated looking mess to a slightly small, incredibly streamlined looking kind of thing. Now, how did they do that? Well, first of all, of course, you know they have this philosophy of the best part is no part. You know, so there's always this, you know, design goal of just getting rid of stuff whenever you can. That way you have fewer things to fail. It's easier to manufacture it, all these things. Now, some of the stuff, it is, you know, it's not a completely fair characterization because the very first, you know, the Raptor 1, that was really pretty revolutionary. It was really the first rocket that had the kind of closed cycle where they really used the maximum power available to them from the fuels. And they had a lot of sensors. Okay, so there's a lot of sensors and probably a lot of extra stuff they didn't really need. They managed to cut that down for the second version. And actually the tests that have been done so far are only on Raptor 2. And even the next test, I think, is still basically using Raptor 2. So Raptor 3 is much simplified. Now, they've gotten rid of a lot of the sensors, which they didn't really need. But they also simplified it a lot because they're using 3D printing manufacturing, there's a lot of pipes that just got absorbed inside of it. So in reality, some of those pipes are still there, but they're all just, you know, they're all just created during the assembly process and totally hidden, which is actually a really good thing because it also means that they have much better control over the temperatures. You know, it's much more robust. They don't need as much heat shielding, or maybe they're getting rid of their heat shields, because everything is kind of protected just within this nice smooth rocket body that they have here. So the comparisons here, I filled in some of the numbers. So the mass has been going down. The weight of the engine itself is going down from 2,000 kilograms to 1,500. The mass for all the associated hardware that you're seeing there also went down even more drastically, and the thrust went way up. The units there are tons of force. So if you imagine 185 tons, that's the force exerted, and then it's up to 280 on the Raptor 3. So they're making the engine smaller, they're making them simpler to manufacture, which has always been a key part of any of the SpaceX stuff, is design for manufacturability and repeatability and reusability. So they're doing all that, and it's kind of made clear by that picture. Okay, I'll just talk a little bit about some upcoming launches. Polaris Dawn, this is one of the private missions. This is interesting because it'll have a spacewalk. That'll be the first time any private people have done a spacewalk. The Starship Flight Test 5, of course, we already talked about. And also we talked about the next ISS mission to take astronauts, either 2 or 4, depending on how they do that. Presumably they'll be sending a couple of empty seats up. Then the question is, of course, who doesn't go and who comes back? Looking a little further out, the Europa Clipper mission is coming up, and this is NASA's, this is a big one with the Falcon Heavy rocket, going to, basically it's going to orbit Jupiter, but it's going to be making a lot of flybys of Europa, which is one of the moons there. That's a really very interesting one, because they think there's subsurface oceans and that sort of thing. So that could be launching in October. Some minor ones we've talked about, AST Space Mobile before. They're the ones that were, along with SpaceX, are promising direct cell phone access from satellites, you know, eventually with everything, you know, talking, not just SMS messaging. And then Dream Chaser, this is the space plane from Sierra that will be also a way to get cargo, just cargo, up to the space station and back. The different thing about that thing is they could bring it back. And so that'll be kind of an interesting one. That's actually it. So any questions, comments? Yeah. I'm sorry, what? You know, I think it's fairly soon. I don't know if it's going to be, you know, certainly not this next test. I don't know if the one after that or not. I think they manufacture so many, they're still willing to use it a few times just to prove out systems, but I don't have a good answer on that. The question was, when are they going to go and start using Raptor 3 engines on Starship for launches? So it's definitely not the next test, which is imminent. My guess is they've already got several other, at least the boosters built, when probably they still have a few more to use up. I don't actually know. Any other?
46 launches since the last meeting.
Yeah, I just didn't have time, and especially since we had 2 months to cover here. Actually, if anyone wants to volunteer to calculate that stuff, it would be helpful. It actually takes a long time to accumulate that information.
Might be a good thing for somebody to just do the monthly launch report. So maybe we could.
Yeah. Or I was thinking, maybe just do it a couple times a year. Because there are other people to summarize this stuff. Even Wikipedia, for instance, you just go there. Maybe it's worth reviewing that every quarter or something. But the problem is there's going to be so many launches, and we're getting too many. When you get to 2 or 3 pages, you can't really go through them all anyway. So at some point, we have to just say, okay, there's going to be thousands of launches. Let's just give some overall numbers. Okay, that's it. So back to your, you want to go back to your agenda, Hank?
Excellent. So now I'll just take.
Oh, yeah.
Is it muted? Okay, good deal. Yes. So venturing into the cosmos, we have Rasha here to kind of to tell us about that. And I guess before we get started, maybe now is a good time to do a drawing for something real quick. I give you this.
Yes.
Does everybody sign up for?
Oh. Set? Set? Yeah.
Excellent. And
Oh, those. No, wait, no, I don't see it. Okay. This one.
The sound.
For the video.
Good.
Is this the clicker?
Yes. And
Oh, it's not? Okay. Maybe there's a delay? Stand by for technical difficulties.
You could probably use the Euro key.
That's oh, you know what it is? We might have a different presentation up there.
Yeah,
Okay.
Does it work now?
It should.
Okay.
Pin that to your.
I want to hold it. It's just cooler.
Okay. The actual microphone is that part of the top.
It will happen eventually.
Hi, everyone. Hi. How you guys doing today? Thank you. I hope you don't mind. I like walking around. So I'm here today to share my story about venturing into a cosmic career, my exciting journey into NASA's Beyond Earth contracting. But before I start, I want to start off with this quote right here. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. And this quote defies my entire journey. I did not give up. I kept on trying. A little more about me. I work at Johnson Space Center. I'm a civil servant, a federal employee working for NASA, and I am a contract specialist. Some of the most exciting things I've worked on, well, actually everything's exciting, But the Artemis 2 through 8 I worked on, and right now I'm in the ISS Commercial Low Earth Orbit department, and it is a blast. I have a Master's of Science in Technology Project Management. I also have a Bachelor's of Business Administration as my undergrad. Out of this world contracts, yes.
I just had a question. So you're saying you already have contracts for Artemis 8?
Yes, we're working on all the missions
That's
already at work, yes. Yes. All right, yes. A little bit about some of the contracts I worked on. When I first started my full-time role at NASA, I didn't know when I was interviewing where I would be placed. I knew it was contracting, but I didn't know where. So I was super excited when I learned I'm going to be working on the Artemis program, specifically the Orion Crew Module. So Orion is designed to be a crewed spaceship that will transport astronauts, specifically the first woman and the first person of color to the moon. So I was, really excited. That's my first full-time job at NASA. And Orion is a critical component of NASA's long-term goals of space exploration, as it plays a pivotal role in the agency's efforts to return humans to the moon. And so there were about 5 contracts at the Exploration Systems Procurement Office, and I was fortunate enough to work on all the 5 contracts. So we have the crew module. It has 2 contracts on that particular module. And then we have the Orion main engine. We also have the laser monitor system and the fuel interagency agreement that I worked on. And fun fact, we order fuel by the pound, plus the cost of transportation. So we did a little math. Right now, I am not working in Orion anymore. I just transferred to the International Space Station and Low Earth Orbit Procurement Office. And I just want to remind you, we are in the presence of greatness right now. I have the acting deputy manager of the ISS and Low Earth Orbit Procurement Office sitting in the back right here, Miss Kelly Rubio. Miss Kelly has been part of the ISS Procurement Office since the ISS's inception. And so she worked on almost every contract that has to do with the ISS. And she's here to support me. She's my boss. Love her. Okay, so one of the things I'm working on is this thing. It's called the Commercial Destination Development in Low Earth Orbit using the International Space Station, ISS, or CETUS for short. And this is basically their original version of what will be replacing the ISS, but it will be a commercial aspect to it, so it won't be managed by the government. And this is the original design. This design has updated since, and it's still in the works, but this is one of the contracts I get to work on. I also, the deorbit contract for the SpaceX, that was awarded by my team lead, and it's going to be part of the work that's going to be on my team. So lots of exciting things going on. All right, so cool things, right? Cool contracts. Now I want to tell you about a little bit about my background. How did I get here? But first, I'm going to tell you a little bit about myself as an individual. So I am a Puerto Rican Palestinian American. And I don't know how many people you guys know that are Puerto Rican Palestinian Americans. Raise your hand. Yeah, I only met 4 of them, and they're all my siblings. So not that many. So my upbringing was unique and different. I traveled a lot growing up, and my upbringing installed in me the confidence to embrace my individuality and the courage to advocate for what is right and the drive to take proactive initiatives. And that's just part of who I am. I know that I'm different. I have a different culture. I'm not the same as everybody else, and I learned to embrace it. And I also learned to embrace other people's cultures. And the values have shaped my approach to life, encouraging me to stand out, speak up for justice, and lead my life with a purpose. So I always like to be surrounded by people who are different than me, who think differently, because that's how I grow as an individual. And I love to embrace other people's cultures, other people's opinions, even if they are different than me. So for example, on LinkedIn, I have 8,000 followers, and I welcome everybody. I do not discriminate, especially if you have a different opinion than me. Let's talk about it and let's learn from each other. And so that's my attitude in life. And over here, I'm with the Student Government Association. There was a great time, diverse group of people at the University of Houston. And there's me celebrating getting my full-time job at NASA. And there's me when I was a little baby. My parents put me in karate before I can barely walk. I don't remember any of those lessons, so don't test me on that. But I understand their message is to be strong, be a fighter, and never give up. So how this journey started. So how does a regular schmegular person like myself, who does not have any experience in aerospace engineering or NASA or anything like that, get a full-time job at NASA? How? Any ideas? Apply, okay. Know some people? Apply to what? Yes, that's great. But if you don't have experience, as you know, NASA's very competitive. It is hard to get into. But there's a way to get in. And that is, when I first started the journey, I was determined to enter into a new industry. So I was working a job before NASA. Let's back up a little bit. I was working a job before NASA, but I wasn't very passionate about it. I was working in the healthcare industry, not the type that helps patients, the type that focuses on making money. Not very passionate about it, and I wanted to do something exciting in my life. So how do I enter a new industry? I didn't know I was going to NASA. I just knew I wanted something exciting, and I wanted an opportunity for growth that aligns with a great purpose. That's what I wanted. And how do I do that? Going back to school. I decided to go back to school for my master's degree, and I knew that internships is the way to go, because with an internship, you're not expected to have experience, but you are expected to have that drive and that passion. And that's something that I already had. I just needed to be a student. So I went back to school. I was on a mission with a purpose. When you go back for a master's degree, it's different, because this time you tried other things and you know what you don't want. You don't know what you want, but you know what you don't want. So I returned to school with a clear mission to learn from others and expand my knowledge. I also took initiatives while I was in school in the University of Houston for my master's degree to invite fellow students and lead projects, managing study groups. I decided to initiate that. It was during the pandemic, so there wasn't a lot of student interactions. So I decided to lead a study session in order to get to know my fellow students more and to learn from them. Another thing, beyond that, I actively led various projects and transformed theoretical projects into practical real-world applications. So we are in school studying project management, and they're giving us assignments to do a theoretical project. I managed to convince my group and lead them into doing a real project. I told them, we're all adults here. Why don't we do something that's real that we can also add to our resumes? And that got some buy-in, and we were all on board. So I was able to lead this team into creating a virtual project that actually helped fundraise money to families, to feed families for the food bank, because during the pandemic, a lot of families were struggling to do that. At the same time, it got us points in our project management class, and we got an A. Thank you. So I'm doing these things, I'm doing a group project, and guess what? People begin to notice me taking new initiatives. I was one of the first people to use a real project for one of my project management class ever. And so people take notice of that. And I was approached with an opportunity. So I never say no to an opportunity, never say no. And this opportunity was to join the Student Government Association at the University of Houston. The person approached me and said, they called me and they actually did and said, hey, would you be interested in helping other students? I'm like, yes, that's basically what I do. I love to do that. What you got in mind? And she said, why don't you join the Student Government Association? I think your skills are going to be very valuable in that organization. And you can help thousands of students. And I said, sign me up. So I campaigned and I got into the Student Government Association. I served 2 terms. And I was honored of serving as both the senator and chairwoman with the University of Houston. And I contributed significantly over 2 terms at the SGA. My dedication and leadership were recognized towards the end, and I was nominated and received the prestigious Center of the Year award. Thank you. So yes, I actually had to campaign for this, and surprisingly, I won. I never campaigned before. And it was actually, this was very challenging because you had to understand the bylaws in order to write resolutions and activate for what students need. And so it was a great learning experience and a great leadership experience at the same time. So this was a great opportunity that I was so glad that that student approached me with. Now, a career at NASA. I knew that I wanted to venture into a new industry. I was thinking more maybe technology. So that's something exciting, right? I didn't think about NASA, but during the pandemic, I was on my phone watching videos, as everybody else does, because we have a lot of time. And I saw a video of a woman that looked like me, and she talked about how she didn't think she would be able to get into MIT, but she applied and she did. And she didn't think she would be able to get into NASA, but she applied and she did. So that stuck in my head for a little bit. I was like, maybe I just gotta apply. But I just kept that in my head. I didn't do it. I didn't apply yet. And then my career advisor sent this opportunity in an email to everybody in my program, not just me, everyone in my program. We were presented with an incredible opportunity to join NASA. This unexpected message opened the doors, a once in a lifetime chance, and I thought, this is my cue. That video was in the back of my head. I want to do something exciting. What's more exciting than NASA? Nothing, in my opinion. So, application to NASA. I started applying, and the application was very extensive, and it required that I get a professor to give me a letter of recommendation. It was COVID at the time, the pandemic was there, so we were able to really get to know our professors. Everything was online. And so I'm like, okay, I gotta step out of my comfort zone and reach out to a professor. I reached out to a professor and I said, hey, you kind of don't know me, but I'm a student in your class. I'm trying to get into this NASA internship. You know, just to let you know, I've been holding and leading this study session for your class every week. And I'm also part of the Student Government Association, just to give you some background about who I am. The professor replied right away. He said, let's meet up and talk more about it so I can get to know you more. And I said, sure. I met with him, and he was so impressed that I was doing these study sessions without his knowledge, just to help the students out. And he quickly wrote that letter of recommendation, sent it to NASA. I haven't read it because it was a way there he has to send it through the portal, so I can't see it. But it must have been really good because I got an email right away from NASA wanting to schedule an appointment to interview me. And I got it. I secured the first and second 2 NASA internships back to back. I successfully secured the first one at Armstrong Flight Research Center, and I did 2 rotations at Armstrong, which is in California, yes.
Where is that?
Armstrong is in California, yeah. It's in the desert somewhere. I think it's a more southern area, closer to Los Angeles. However, everything was remote, so I still kept my other job because I was still working, and I was going to school, and I was doing an internship. That's what happens when you don't have to commute. You have a lot of time. But also, I was doing a lot. So during this time, I decided to take initiatives, because remember, that's part of who I am as a person. So I took an initiative to learn about Six Sigma, and this led me to earn a certification in Lean Six Sigma Green Belt. Now, this is something that interns don't usually do, but because I want to take initiatives, I asked my mentor if I can participate in this, and he said, go for it. I had a great mentor. And this was not easy because you have to do 2 weeks training, you have to take an exam, you have to pass the exam, you have to do a project, you have to make sure that project is quantifiably improved NASA, improve the process, and then you get awarded the certification. And so I was very fortunate to be able to do that. It was challenging, but it was definitely worth it. Yes, it was a process in managing the excess property within NASA. Yes. So property that NASA is no longer using, that we have to manage that process. We don't just give it away or, yeah. So property management. Property can be rocket ships, desk, not real estate. Yes, good question. Yes. Yes, it can be a chair from a rocket ship. It can be a boat. Yes. Actually, there was some, yeah, boats and stuff. But it has to go the process first. Yes. Great questions. So, towards the end of this rotation, at Armstrong Flight Research Center, 2 rotations, I got some bad news that my mentor won't be able to do a 3rd rotation because he's getting a lot of workload and he won't be able to manage mentoring. So I had to apply again to NASA. And this time, I don't know why, it was a lot more challenging. I was applying to I probably applied to 10 to 30 internships. And these are the OSTEM internships. That means that someone else pays for us to work at NASA. Now there's another internship, it's called the Pathways internship. That one is more challenging to get into. And that one, you are officially a federal government employee, and eventually you might convert to a full-time job, but there's no guarantees. But this one is not as competitive as the Pathways, but it's still very competitive. So I applied again, and this time it was very challenging. I was coming close to the end of my rotation where I had to give up my laptop, and I had nothing yet. No calls, no nothing. And there's this one particular internship that I applied to it a few times. I don't think we were allowed to do that. I think they changed the process now. But there's one particular internship that I really wanted. I even tried to hunt down the project manager, and HR lady told me, you can't do that. We can't. And then I was like, okay, can I give you a letter to give to the project manager? And she said, fine. So she gave them to the letter. And right before I was about to log on, I was feeling down, I got good news. I got the internship that I really wanted. This is my 3rd NASA opportunity. Now, this one, after submitting numerous applications, this is my top choice, and this position is called the Aircraft Project Management Intern fancy, doesn't it? It sounds really fancy. And it was a great experience. So I contributed to NASA's Airborne Science Program, and I provided support for this magnificent aircraft, the C-130. How many people know this aircraft? It's a military aircraft. It's used a lot for cargo. And I think the Mars rover was transported on this airplane. So this was still remote, but I was able to meet the pilot because he asked me if I wanted to meet him when he landed in Houston to refuel the aircraft. And I said, of course. So this was my first taste of like the first time I actually touched NASA, something NASA. But everything else was remote. So this was a great experience. Now, this whole time, I was applying to full-time opportunities. I was applying to NASA. I was applying to other jobs too, because I still kept my other job, even though I'm not very passionate about it, but I needed a full-time job. I needed to keep going. So because I applied to all these jobs and my internship was running out, I needed a job. I got this opportunity. No, not in NASA, outside of NASA. I was still getting rejected, by the way, from NASA's full-time opportunities. I was getting rejected over and over and over till it became normal. So this opportunity, I was brought on board as an IT analyst at one of a leading Fortune 500 companies, and I was tasked with addressing an ongoing problem that they have been wrestling with the past 2 years. Now, they saw that I have that Lean Six Sigma certificate and that training that I've received from NASA. And they saw that as very valuable. And that's what they wanted. So they interviewed me. They liked that I knew what I was talking about when it comes to process improvement. And they hired me. When I was working there, I was able to help them figure out their problem that they've been wrestling with for 2 years in a few weeks' time. And I was able to solve that problem for them. And I was able to track down $300 million worth of data center assets. And that was great. But at the same time, that was the first time when my NASA internship was over and I had no connections with NASA whatsoever. And I felt sad. I was still applying to NASA. I was still getting rejected. But I was applying for the pathways, which is the more competitive. I was done with the other internship. I was applying to the more competitive roles because I was ready to move to that role. So I put that on my resume. I wanted to impress NASA, and they were impressed because I kept reapplying to NASA, and I got the Pathways internship. So the Pathways internship is a significant milestone in my career because I took my oath of office and I became a civil servant. And I stepped into a role as a federal employee. So that moment is very pivotal because my professional journey provided me with an exciting opportunity to work on groundbreaking work and showcase my skills to NASA and potentially land a permanent role with NASA. So I'm not out of the woods yet. I'm still an intern, but this time I'm a federal intern. So I did the interview with NASA. Obviously, I got the job, but then I found out that we are no longer remote. We've got to return to the office. And this opportunity was in Las Cruces, New Mexico. So I had to reject it. Just kidding, I went. I never say no to an opportunity. So this accomplishment required unwavering dedication, including frequent, extensive travel and long distances that NASA did not pay for. So I got a huge pay cut from going to a tech job at a big Fortune 500 company to go back to an intern where I had to pay for my own transportation and hotel, rental car, food, a lot of stuff. And it gets pricey. But I knew it. I knew it was good for me to go because despite the challenges, I persevered, knowing each step brought me closer to my ultimate goal of a permanent position with NASA. And this is me at White Sands National Park. Beautiful park. The sands are so white, your brain thinks it's snow, but it's actually not. And so you get confused when you first get there, but it's amazing. Highly recommend you guys go to it if you get a chance. Great question. Yes. This is my first contracting role too, as a contract specialist. Yes. So I took more initiatives. I decided that I want to make sure NASA wants to keep me as a full-time, in a full-time role. So I took initiatives. I created more process improvement, innovated new ways to do things. And apparently that was impressive for them because I was nominated with and received an award. I received a recognition award from NASA during the end of this internship. And this was for my outstanding contributions to the pathways as an intern and a testament of significant effort and dedication I poured into my work because I really knew that I wanted to be a part of this. This recognition paved the way for a new opportunity. So I successfully secured an interview, which is very hard to get, for a full-time position at NASA, bringing me one step closer to achieving my career goals in this wonderful organization. I have never gotten an interview to a full-time position at NASA before, just the internships. So this was big. So I applied to this internship, this full-time opportunity. It was for Kennedy Space Center, and they really liked me. They selected me as the top candidate, and then I wasn't offered a position because I checkmarked the wrong box in the application saying that I would not work for any amount less than the GS level, and they could not extend an offer to me because of that. So I gave up and went home and cried about it. No, just kidding. I applied again. I kept on applying. And guess what? This time, I got the job. I finally got my full-time job. And I got it. I got my goal. I was offered a full-time job, specifically at Johnson Space Center, my preferred location and my top choice because, I kind of live here. And so this opportunity was perfectly aligned with my aspirations and brought me closer to contributing to the NASA mission. And when I was going through this journey, I promised myself not to graduate from university until I get a full-time role at NASA. And so after I got my full-time role, 6 months later, I graduated and got my master's degree. Now, I'd like to play this short video just to kind of sum up the work that I got to work on. So NASA, of course, is moving from the low Earth orbit. We're commercializing that part as I'm working right now in the ISS and moving more into deep space exploration as I worked on with Artemis. So this video kind of sums up my work, everything I talked about, but in a really cool way, though. So let me just play that video. Do I click next? Okay.
NASA will be one of many investors of commercial development, opening space to more people, more companies, and more ideas. An orbital economy inspires new opportunities for commercial partners to enable research, commerce, and unique experiences. NASA's commercial crew and cargo partnerships launched this path to incorporating space into our economic sphere from NASA's 2 decades of continuous human presence in space. Private space flights enable more types of people to visit space. Innovation in commercial space stations powering technological advancements that benefit our daily lives. Low Earth orbit transportation and destinations in the hands of the private sector frees NASA resources for human exploration to the moon and beyond.
Cool stuff. Okay, final thoughts. In conclusion, embrace the courage to dream boldly and set ambitious goals. Consider rejection not as a setback, but as a valuable chance for personal growth and development. Continuously strive for self-improvement, recognizing that persistence is key. Keep pushing towards your objectives and remain resilient, even if it means giving it one more try. Thank you. Yes, I have a question right here.
Contracting. Share with everybody what you're doing in terms of your certifications, the education you're having to achieve, and how you're taking that back to the office with your colleagues.
Yes, so in terms of certifications, there is extensive training in the contracting role. So right now I'm a contract specialist, which is essentially a contract officer in training. But we train and work at the same time. So there is a certification called the Federal Acquisition Contracting Professional, and so I have completed 4 classes to get that done. I just need to take the exam, so I'm working on that. And so that will make me certified, and then eventually I will get a warrant, and I would be a contracting officer, which means that I would be the one awarding contractors such as SpaceX and them the contract, and which means nothing goes through, no work gets done until a contracting officer signs the paperwork. So we give it the last stamp of approval. It's a lot of responsibility, so I'm taking my time with it. But yes, in terms of training, I'm training and I'm on my way to becoming that. Any other questions? Yes.
All right, I'm gonna go back to the basic. I don't know what a contract specialist is. What do they do?
Great question. What is a contract specialist? Okay, so around 80% of the people who work for NASA are contractors, and NASA NASA pays for more than 90% of the NASA budget goes to pay for contractors and contracts. And so we, as the, in the procurement office, we have to award the contract. We get together with the technical people, see what are the needs, the agency needs are, and then we make sure that we manage the process of awarding a contract and the competitive process during the bidding and the solicitation. And so we manage that to make sure we abide by the Federal Acquisition Regulations, which is law. And then after the contract has been awarded, we manage that contract, making sure that before they receive each payment, that a milestone has been completed, that the work has been verified, and that government accepts the work. And then there's another process, which is the contract closeout. We have to make sure that everything was delivered, approved, and the payment has been made in order to officially close out a contract and start all over again with awarding a new contract. So great question.
Okay, so then essentially it's like, if we got this project, we need people to do these jobs. If you want to bid on these jobs, talk to this.
Yes, pretty much.
And then, like, once you get the contract, like, you don't do these things, you're not getting paid.
Exactly. That's a great way to sum it up. Yes. Yes.
Okay, as a mother, well, thank you so much for being here today.
Thank you.
It's a blessing to be able to hear your challenges and how awesome you are. Okay, as a mother of a young 11-year-old that dreams and thinks about space all of the time.
Oh, that's wonderful.
Were you that way at 11? And if so, what would you say to your 11-year-old self?
I love that question. And I was thinking about that. I see the young people here. You guys are amazing. You guys are amazing. I think you're young, right? You're pretty young. You guys are amazing. You being here, being exposed to this is an opportunity for you to know what you want and what you want to pursue in life. The thing about me, when I was a child, I never thought I could be part of NASA. I didn't think it was possible. So for me to be here makes me want to encourage young people that you can do whatever it is you can and you want to do. And you can do anything, actually. Let me rephrase that. You can do whatever you want to do if you work hard and keep applying and give it one more chance and never giving up. So that's my message to you guys, because I wish I had somebody to tell me this, because I thought NASA was too intimidating and too technical for little old me. But here I am. So if I can do it, you can. So that's a great question.
Thank you so much.
Thank you. Any other questions? Oh, okay, but I think you had a question?
Yeah, I'm just curious.
Yes, great question. We do actually have a little bit of accounting and math in it, along with law. But we do have a budgeting office, but we also have to verify some of the cost and things of that nature. So we do spreadsheets. Yeah. So there is a little bit of that. And in terms of funding and, to make sure that we're on board with funding. So that, yeah, we definitely deal with that aspect a little bit. But we also have our budgeting and finance office departments that help us out as well. But we have to ensure that everything's accurate. Yes.
Rosh is very inspirational, not just to me, but in our office. And the telling thing about Rasha in this presentation was about never giving up and trying this that one more time. And the chart that resonated me was never say no to an opportunity, which is something I believe. So you showed all of this pre-NASA. How do you think saying no to an opportunity applies to you now that you are at NASA in your career?
Oh, Kelly, you're hitting me with the tough ones. Look, I still never say no to an opportunity. Nathan asked me to come here and talk about my story, and I said, absolutely. Thank you, Nathan, because it is a pleasure to be here to share with everyone. So yeah, I'm still on board with that one. What? Oh, well, I'm kind of from all over. I lived in California and the East Coast as well. That's why I had a unique upbringing. I also lived in Canada. So, but I consider Houston my home, because once I moved here in 2007, I liked the gas prices and I like the cost of living. Yes, the economy is great. So this is considered my home. So, yeah, I live in Spring. No. Anybody else?
Well, while people think about their next questions, it's not quite awarding contracts, but if you wouldn't mind, could you help me with awarding some door prizes?
Yes, I'd love to.
So,
yeah, I'm gonna butcher that name. Oli? Did I say that right? Oli. Oh, okay.
So I got a PJ's gift card for you, and we have a lot more to give out. So.
Okay, more?
Yep, 6 more.
Rachel.
Rachel? There you go.
Yay! Peter? And how many? One more?
One and then 3 books.
Oh, okay.
Yep.
Valerie.
Excellent. There you go.
Next one is Eddie.
Eddie?
All right.
There you go. And then 2 more.
2 more. Patricia?
Oh, there you go.
And one more. Last one is Palum? Palum? Yeah. Yay.
Excellent. And did anybody have another question for Rasha?
Contract for the other 20%, which is, I assume the 80% is sort of stuff that you've done. There's a pathway to it. You've done it before. It's like this year's contract for fuel for all the trucks in NASA, or contracting for a whole bunch of computers to provide for the engineering staff. Well, how do you figure out how to deal with stuff that has never been done before? Because now there's no guidelines on very unstable ground. You have to sort of estimate.
Yeah.
You go out and contracts for that.
That is a great question. So, almost every contract at NASA is something that's never been done before. We're doing unique things here. What we do is we have this thing called Industry Day, where we showcase what the government is looking for in terms of the technical skills and abilities. And we have the contractors attend, those who think they are capable of presenting that type of work, just so they can ask questions and learn more about what NASA needs. We get together with the technical engineers, and they form the technical requirements. But before they do that, we have already met with the industry and let them know that, hey, this is possibly something that we're going to be looking for in the future. What capabilities do you have? What can you do? So we can learn. Maybe the industry has a capability that we don't know about at NASA. So this is their time to show us what they got, and also their time for them to ask us questions, so we know exactly so they know exactly what we're looking for. And so once we get with the technical folks, and we already passed the Industry Day, we researched to see what our limitations and obstacles could be. That's mostly the technical people. We do a solicitation, and we could make it competitive, and people bid on it. And when they bid on it, they propose their technical abilities, also the cost. And we go from there. We evaluate each one of those bids, and we select a company to award this to. So great question. Yeah.
And Rasha, we have a question online from Cassandra. She says, what advice do you have for someone who has dreamed of working in the space industry, but struggling to find opportunities where your current field of work could translate?
Definitely explore internships. I think internships are great because they're not expecting a lot of background experience. So it's a way for you to learn. Keep applying. Don't give up, even if you get rejected. The application process alone is a learning experience on its own. You really have to know what you're like. One check mark on the wrong box can get your application rejected. So the more you apply, the more you become better at the application process. And this is the most important thing, because that is the first thing they look at, your application. It has to be top notch. So definitely focus on that. Take advantage of internships if you don't have any experience. And once you're in there, give it your all. Take initiative and see if you can get those awards and recognitions to make you stand out.
And Cassandra, didn't know if you had like a follow-up question. Feel free to unmute and ask it if you wanted to.
Yeah. Sorry, I just was. Thank you for your response. I've just been really interested in trying to figure out how nursing can start beginning to kind of merge with the space industry, especially now that's becoming more commercialized, and they're thinking about setting for instance, like space tourism and things like that. So, yeah, just, trying to figure out, I almost feel like it's on the forefront of it. So, when you look for opportunities, it's very much like, actually during your presentation, I was looking at internships, and, they're very much like, masters of some specific science program, that none of them specifically health related except for medicine, of course. So, just, any other tips or tricks you have for trying to make that jump would be appreciated.
Yeah, that's a great question. I'm not sure. That's not really my expertise in the medical aspect of NASA, but I do know we do have physicians that work for NASA. I think we have a Kelly, if you can help me out, I think we have clinics at NASA that we do have like doctors and medical people checking on astronauts. So Yeah, I think Kelly would elaborate on
Yeah,
that.
we have the human health performance contracts. Right now is with KBR. Used to be Wiley contractor, and they do all the crew medical, flight surgeon support. They're all contracted, so they may want to get in touch with KBR in Houston and start from there.
Yep,
I know at
KPR.
JSC, we have the clinic, and every year I have to go for a flight controller physical. So we definitely have nurses through the contractor, yeah. Oh, the people at the JSC Health Clinic. Okay. Okay, that makes sense.
So there is a chance for you in that field as well. Yes.
Solicitations, is there a place online?
Yes, it is sam.gov.
Okay.
All of the NASA solicitations are federal government. They post it there.
Gotcha. And then like, what is the smallest thing, I guess, that you guys have solicited for?
I'm not sure, Kelly. The smallest thing that we have solicited for? Pens and pencils.
For the federal government, I mean, it's not just space rocket vehicles.
Yes.
You know, it's how to run the facility and do the grounds maintenance or things that we do. I can't say what would be the smallest though. But.
Yeah, we do use pens and pencils. Patricia. Oh, sam.gov. Yes, Sam. Plain old Sam, yes. Sam.gov. What was it? Yeah, you got. Yeah, contractors need to create an account. Yeah. Yes.
Out of curiosity, does the government use like pens and pencils for like from the grocery store, or do they use like more specialized or more expensive stuff?
I think we look for the best value. Always, always, always best value. So it could be more expensive. I don't know if it's the best value. We'll get it. All right.
Oh, very good. Thank you so much,
Thank
Marsha.
you.
I had a bit of thing I wanted to give you.
Oh,
So
wow.
to give you your own starship.
Oh! Yay! Oh, that is amazing.
It's 100% reusable, so it'd be the cheapest.
Oh, thank you. Thank you so much. I appreciate it.
Maybe I could get a
picture?
picture.
Me and my little starship. Oh, I love it. Thank you so much, everybody. Thank you, everyone.
Join us at PJ's if you want to just hang out and chit chat. And I know 5 of y'all at least have gift cards that you're burning to use. So thank you all so much for coming, and hope to see you all next month.
Doesn't have to do until you get to ride a real one.
Yes. Yeah. Oh, one day. One day. Never give up. Thank you.
You inspired my little girl.
Oh, you are amazing. Hello. Hi, Brooklyn.
So,